Alright, so here we've got to simplify. It's an addition. Okay, so we're adding together two different surds. But of course, root 45 and root 125 are not like. They're not similar, right? They're not the same. Imagine if we had, 3x plus 2x, you'd be happy to say that's 5x. But if you had 3x plus 2y, there's not a lot we can do with that, right? So it's a similar thing with surds. So what we can do is we can actually simplify first before we add. And the best way of trying to simplify surds is by breaking it down into factors. Now we don't need to go down all the way to prime factors, we just have to choose some really nice factors. And so I'm listing the nice factors here. And you can probably see why these are nice factors, right? Because they're square numbers. So if you can choose to break down the existing numbers using some square numbers, then life will become a little bit simpler. And let's go see why. So 45, I think that's 9 times 5, right? So if I do 9 times 5 instead of root 45, then over here, instead of 125, right, you guessed it, 25 times 5. Now the reason why we've done that is because we have that nice rule that applies here. We can distribute the square root operator. We can distribute this root operator over the multiplication. Okay, so what does that mean? Well, it means that we can square root each individual number and multiply the answers together, and that's the equivalent of multiplying the numbers together first and then taking the square root, right? So that's the key to these types of questions. When we simplify a surd, we want to break it down into smaller factors. And of course, if one of the factors is a square number, that will become 3 lots of root 5 here, and that will become 5 lots of root 5 here. And can you see now that looks a little bit like 3x plus 5x? You'd be happy saying that would be 8x. So the answer here is 8 lots of root 5, or 8 root 5. Now you can go ahead and break down 45 into prime factorization, right? 3 and 15, and then 3 and 5. Okay, so root 45 would be the same as the square root of 3 squared times 5. But you're kind of just then breaking it down into this. You're using the same rule as before. And of course, that just gives you 3 root 5 again. So breaking it down to prime factors is also absolutely fine. Maybe a bit longer. If you can spot right from the off which particular square number you could break down and use, then that would be the most efficient technique.